So wonderful, algebra students. These are your notes for 3.14, slopes of parallel and perpendicular lines. So the first thing we're asked to do is plot and label the following points on the graph. So I'm going to hit pause and plot my points, and why don't you do the same? Okay? So there's my points, A, B, C, and D. And in part B, it tells us to use a straight edge, which means a ruler or maybe your ID or something, to connect the points and create these lines, A, B, B, C, C, D, and D, A. So I'm going to pause again and do that. And of course, I can't use a straight edge on the iPad, so I'll do my best to make them look beautiful. But you do the same on your papers. Okay, so there are my lines, A, B, B, C, C, D, and D, A. And then we are supposed to determine the slope for each line. So let's do that, starting with line AB. And we're going to do the rise over the run. And so on that one, we see the slope is 3/2. On BC, we see the rise over the run is -4/6, and we can reduce that to -2/3. And then on CD, again, we're going to do rise over run, and it has positive slope of 3/2. And then finally line AD, again, let's do rise over run, and again, we have the -4/6, which we can reduce to -2/3. Okay, now let's answer the questions below. So, on question 2, it says, what do you notice about the lines AB and CD, and what do we notice about their slopes? So, AB and CD, let's go back and look at our picture. AB and CD appear to be parallel lines, and then you'll notice that their slopes are the same. So let's write that down. So the lines are parallel and the slopes are the same. Now take a look at B, C, and D, A. So exactly the same. Those slopes are the same and the lines are parallel. Okay, now we need to look at CD, line CD and line DA. Now if we look at those lines appear to be perpendicular. They may create a right angle. And let's look at their slopes and see what we can figure out. So we can say that the lines are perpendicular, but what about their slopes? The slopes are, for CD, the slope was 3/2, and for DA, the slope is -2/3. So what do you notice? Do you see that the two slopes have been flipped? That's what we call the reciprocal, when you take a fraction and flip it. And whereas this one was positive, the first one was positive, the second one was negative. So their slopes are not only reciprocal, but they are opposite. So let's write that. The slopes are opposite and reciprocal. Now, it asks us to check the same thing about lines AB and BC. And again, if we look over here at A, B, and BC, you can see they create a right angle as well. So they are perpendicular. And look at their slopes. Slope of 3/2 and -2/3. So it's the same. And I'm just going to write same because I wrote big on there. The lines are perpendicular and the slopes are opposite and reciprocal. So what can you conclude about the slopes of parallel lines and perpendicular lines? Why don't you write in what you think? It should be pretty obvious, and then I'll come back and fill it in for you. So hit pause and do that. So parallel lines have the same slope, and I wanted you to note that when I refer to parallel lines, I like to use this symbol, the little two parallel lines. Perpendicular lines have opposite and reciprocal slope. Opposite meaning if one's positive, the other's negative, and reciprocal meaning the fraction's been flipped. And I like to use this symbol for the word perpendicular, a little right angle, kind of an upside down T. Now, it says if two lines are perpendicular, the blank of their slopes is blank. Okay, so I know you probably don't know what I'm looking for there, but I want to show you that if we take perpendicular slopes, and I'm going to go back up here to where we were looking at it earlier, up here. If I were to take the two slopes, 3 over 2, and multiply the other one, negative 2/3, let's multiply them. So we get negative 6 over positive 6, and negative 6 over positive 6 is negative 1. That kind of leads us into what we want to say, that if the two lines are perpendicular, the product of their slopes, meaning if you multiply, remember the product is when you multiply, of their slopes is negative 1. And that's a good way to check, to make sure lines are perpendicular, multiply their slopes, and make sure they equal negative 1. Okay, now let's flip to the back of our page and take a look at some of those activities. Okay, so on question 3, it says, given the graph to the right, what is the slope of the line? So we want to find two pretty points and do rise over run. So I'm going to use the x-intercept and the y-intercept. And if we do rise over run, we can see that the slope is positive because the line is going up. So we have a rise over run of 3 over 6, and we can simplify that to be 1/2. So it has a slope of 1/2. Now, knowing what we just said on the front side, do you think you could fill in the lines here? What's the slope of a parallel line? What's the slope of a perpendicular line? And then check the perpendicular slopes. So I want you to try and do that. Hit pause and do that yourself. Okay, so remember, parallel lines have the same slope. So a parallel line has a slope of 1/2. Perpendicular lines have opposite and reciprocal. So the first slope was positive, so our new perpendicular slope would be negative, and then I took the fraction and flipped it to negative 2 over 1, which we can simplify to negative 2. And then it says check the perpendicular slopes. So negative 2 over 1 times 1 over 2 is negative 2 over 2, which equals negative 1, and so those are perpendicular. Okay, I want you to do number 4 yourself. I want you to figure out the slope, get the parallel slope, perpendicular slope, and then check them and see how you do with that. Okay, so I found the slope to be negative 4. You could pick any two of these points to figure out your slope, and I chose 6, negative 8, and 11, negative 28. So I did that right here and found the change in y over the change in x, which is negative 4. So the slope of the line is negative 4. Parallel lines have the same slope, so that slope is negative 4. Perpendicular lines have opposite and reciprocal, so the opposite of negative is positive, and then take 4 to make it into reciprocal. We put a 1 under it, and then you can flip it. And then to check the slopes, we multiply the two slopes together to get negative 1, and that proves up that they're perpendicular. Okay, let's try number 5. Okay, again, I think you are perfectly capable of answering these 4 questions without my help. So I want you to hit pause, find the slope using these 2 points, and answer the questions. And then come back and check your work. Okay, so finding the change in y over the change in x, I found the slope to be 3. So there's our slope. Parallel slope is the same. It has a slope of 3. Perpendicular slope, we want to make it the opposite and reciprocal. So the opposite of positive is negative. And then to flip a 3, we're going to put a 1 under it, and then flip it, so that's negative 1/3, and then you can check your slopes by multiplying and make sure they equal negative 1. Okay, now number 6, let's do together. It says, given the linear equation y equals 8, what is the slope of the line? Well, this is a special line because it only has a y in it. There's no x in that line. And so when you see lines that only have y's, that should just send bells off in your head. Ding, 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 ding. It's a Hoy line. And Hoy lines always are y equals something, and in this case it's y equals 8. And so this little O right here is to remind you that Hoy lines have what kind of slope? They have 0 slope. And so the slope of a parallel line, remember parallel lines have the same slope, so it's going to be 0 slope. Now, remember, a Hoy line is a horizontal line. So what kind of lines are perpendicular to Hoy lines? Well, ding, 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 ding. I hope you remember that it's a Vox line. A vertical line is going to be perpendicular. So the slope of a perpendicular line is going to be undefined. That's what that little u is right there. Undefined. And it says, write an equation of a line that's perpendicular to the line that was given. Now remember, the given line was a Hoy line, y equals 8. So the equation of our Vox line is going to be x equals something. And that y equals 8 line is going to go to infinity. So you could pick any point along the x-axis and it would be perpendicular to the Hoy line. So I'm going to say, how about x equals -2? That'll work. Or you could say x equals 10. Or you could say x equals 1012. Whatever. It just has to be an x line, a Vox line. And that'll be perpendicular to your Hoy line. Okay, there's your lesson on parallel and perpendicular lines. And we'll be doing more with these tomorrow in your lesson, so make sure you know how to do it. Okay, see you in class. Bye.